Hello, ready? Jai Hind, dear students. How are you, all of you? I wish you all are so much great at the home and learn all the things very perfectly. Yes, we know there are some times are left in our board exam, beta, just few days, just 2 or 3 days. And now there is a time to prepare a proper MCQ for your board exam. So let's begin today's session. Jai Hind wala Jai Hind. Late OP. It's not late OP, dear. It's just a 10 second. Chaliye. Hello, 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 hello. Okay, so what is exactly for physics was chemistry? So dear, in this session, we are going to discuss about the physics particularly. We are planning for some important MCQ for all of you. Actually, during the entire year, there is no any session for the English medium students, but especially before the exam, we are planning also something for English medium students. So in this session, we are going to take some of the important MCQ, not just an important MCQ, but also you can say it just contains some important concept. If you are going to complete that concept properly, we can say there is some type of question are there in your upcoming exam, in exam of 2026 physics. So let's get ready. We are going to see all the MCQ as per the NCERT syllabus and which is related for your exam, dear. So let's begin. So initially, what we are going to cover in this session, total 14 chapter are there as per the NCERT. So we are taking some of the MCQ from each and every chapter. So total numbers of MCQ from the chapter number 1 to 14, and all the important MCQ, not just an MCQ, but I can say dear, there is all important concept are going to be covered. So MCQ in conceptual way in this session we are going to cover. So let's begin with the initial chapter of our syllabus. So are you all ready for today's session? If you are ready, then just show your enthusiasm in the comment section. Hello, hello, hello. Standard physics chapter number 12, ray optics is difficult. Okay, dear. Next. Hello, beta. Hello. Okay, so some students are going to write that please speak something, some matters in Gujarati. So initially, I just want to say in which language you are comfortable, dear, in just English medium or in English with Gujarati, in English with Hindi, or try, sir, try to speak in Gujarati, Hindi, English. We are ready for the combination. Hello, 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 hello. Yes. Okay, so for the Gujarati medium, we are going to continue one session at 7 p.m. It is also an emergency classes. Some important things we are going to discuss over there, not just a discussion. Also, we are going to learn some of the content which we are left during our entire study of the year, dear. Yes. Oh, how much MCQ over there? So we are trying to complete 50 plus MCQ over here, and all are from your PYQ and important concept. So let's begin here. Very first MCQ we are going to see, but there is definitely one thoughts in our mind. Why it's need to be studied, sir? Is it some scope that if we are not going to study and we can do something? But currently, just I said here, on this time, on this situation, on this day, there is just one way: learn properly, complete your work, achieve a proper result, and then think about each and everything what you want to think, dear. Okay, so let's begin with our actual work. And first MCQ from our lovely chapter number 1. So let's begin. Also there is poll. Chaliye. Okay, so 90 seconds available there. Just start. Okay. Hello, 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 hello. For Gujarati medium, we are going to start at 7 p.m. Currently, a session for all the English medium students who are learning in GSEB board here. Okay. Chaliye, perfect. So in a very initial MCQ, what they said here, a charge Q placed at the center of one of the face of the cube, then the electric flux linked with the cube is. So given data is so much easy, and we can just assume that from which of the fundamental this question is going to be asked. uh let's just guess in the comment section. So we can say this question from the Gauss law. Yes, definitely, beta. A question from the Gauss law. And what we know about the Gauss law, just try to remember here. Try to remember for a moment. Yes, sir. We are no the Gauss law. So by the Gauss law, we can say the flux phi connected or the passing through any body which is equal to sigma q, the total charge covered by the body divided by epsilon naught, vacuum permeability or permittivity. So it's a vacuum permittivity, dear. So here we can say that phi is equal to sigma q upon epsilon naught. So there is a one twist in a question. If they are saying us a one charge capital Q or small q completely at the center of a cube, then we can say the flux entire with the whole cube is sigma q by epsilon naught, and our final answer is phi is equal to q by epsilon naught. But I just request you to read the given data properly. What they say the charge placed at the center of the faces. So whenever, dear, there is a charge at the center of the faces, so what we can say, sir, if there is a charge at the center of the face, we can say it is divided in the two cube. It is divided into two cube, and one cube is the imaginary part. So here I just take one imaginary cube over also. So just take a one imaginary cube over here, and I can say the total amount of charge q. Yes, it is going to divide half in both of the cube. Okay, sure, perfect. So there is a total numbers of charge q. It is divided into two cubes. So now I can say the amount of charge with just one cube is equal to half of the q. So it's q by 2 divided by epsilon naught, and the final answer is q by 2 epsilon naught. And what we can say, the new flux by just a one cube as the given data, we can say it just actual phi by 2, and answer available is q by 2 epsilon naught. Option B is the better answer. Hope you get the point. चलिए, okay, so stop the poll, view the result. Oh बाप रे, oh ये क्या हो गया यार. चलिए, sorry, I think I just give you a poll for the thumbs up or thumbs down. Okay, no worry. Perfect. Okay, so let's see another question. Just start. I give you a 60 or the 90 second, and a single choice question is the perfect. Let's begin, dear. Let's begin. Okay, how many MCQ will be asked from this lecture? So dear, I cannot that way tell you that there is 50 MCQ out of this 50 MCQ, 40 MCQ out of this 40 MCQ, but I can definitely say that all the concepts are going to be covered in this session are important concept. So there is multiple concept are going to be seen in your upcoming exam 2026, right? So like that way I cannot speak anything that definitely there is 15 MCQ from this session. No any wrong sentence over there. Just learn the concept properly and apply it properly, so it help you for improve your result. Okay, perfect. Gojo ji present here. Okay, sure, dear. Okay, so just read the given data. What they say, the electrostatic force on a small sphere of a charge is 0.4 microcoulomb due to another small sphere charge 0.8 microcoulomb in air. So they given the medium as air between two charge q1 and q2. What is the distance between two sphere? So I think it is easy concept and easy formula. Whenever there is a two charge and a distance between them, they ask for one force between them, and it's an electrical force. So we can easily say that the electrical force between any of the two charges, we are taking it as a so simple equation that kq1 q2 divided by the r square. R is the distance between two charge. So finally r square is equal to k Q1 Q2 divided by the force available. Now just put down all the values. So K, dielectric constant, and we know the value of K is equal to 9 into 10 raised to 9. Yes sir, definitely, it's so easy MCQ. Now the value of first charge. The first charge is a zero point 0.4 microcoulomb. So 0.4 micro it means 10 raised to minus 6. The another charge is minus zero point 0.8 microcoulomb. So what actually it's indicate? There is a one charge is positive and another charge is negative. So there is attractive force between these two charges. And if both the charges are same, like both are the plus or both are the negative, so we can say repulsive forces over there. But it is no issue. It's not a matter over here. Just we have to find out the value for the distance between two charges. So just put down the value for that charge. That value is 0 0.8. Okay, and micro, so I can say 10 raised to minus 6 divided by the force between two charges given as 0 0.2 Newton. So let's begin the calculation. Sir, 0.2. Cut the 0.4 by the 2. Okay, so 9 into 2 becomes 8. And 8 into 18. Yes. 18 into 0.8 becomes, I think, 1. Okay, it's r square. Sorry dear, whatever it is for r square. So I can say r square is equal to 9. 2 multiplied by 0.8, it becomes 1.6 into 10 raised to 966 going to be plus 3. So just give a 1 10 to 16. So r square is equal to 9 into 16 into 10 raised to 2. So finally it's easy. There r is equal to, okay, so sorry, it is minus 2 minus 2 minus 3 minus 3, so minus 4. Sorry, 10 raised to minus 4. So finally I can say the root of 9 is equal to 3, the root of 16 is equal to 4, and the root of minus 4 becomes minus 2. So 4 into 3 is equal to 12, and 10 raised to minus 2 becomes divided by 100, and the answer is 0.12 meter. So the distance between the two charges is 0.12 meter. Option C is the perfect answer, and I hope that many of you are going to click the correct answer. Okay, that's perfect. But 94.12% students are going to click the perfect answer. Too nice. Now it's an so simple MCQ here, but it's an important concept. During the entire year, what we are going to learn? So the total charge. Yes, the total charge is equal to N into E. The charge is quantized. Yes, I'm totally agreed here. I'm totally agreed that charge is a quantized. But whenever there is a specific numbers of electron and proton are given, so we have to just take care about one things that so numbers of proton has the positive E. Yes, perfect dear. And the numbers of neutron has the negative E charge. So finally I can say that numbers of proton minus numbers of electron, and E is the common factor. So here they say that if a body contain N1 proton, so the numbers of proton is N1, and the N2 electron, so number of electron is N2, and by the common E, N1 minus N2 into E. So option B is the perfect answer. No sir, option A is the perfect answer. That's fine, easy MCQ. Now it's an important things there. Not just only this question, but from each and every chapter you have to complete the important equation, by that equation important unit, and by that unit important dimension formula. Never miss this for each any of the chapter dear. Just put all the things, beta, just put all the things and sit properly and start with the chapter number 1. Write down all the equation initially, then write down all the units for entire fundamental quantities available there, and after that practice for dimension formula. Because if you are going to check the past paper, definitely there is 4 or 5 MCQ related to directly from unit or the dimension formula. So maybe you tried this. Okay, so start by yourself first, then I'm going to complete. Okay, so begin here. Begin. Okay. Dear, do not worry, Yug Patel ji, for the Gujarati medium, we are going to meet at 7 p.m. sharp. And there is also one important session is arranged. So not worry, we are going to meet at 7 p.m. But currently this session is going for the English medium students, and there is MCQ practice specially. So if also you want to continue this session, you can do for your practice. Yes, perfect. Great. Okay, so let's begin. The dimension formula for the capacitance. So initially what we need, we are just remember a one question for the capacitance, and which is easy. So generally what we think that C is equal to epsilon naught A divided by D. But from here you have to also think the exact unit or the dimension formula for the vacuum permittivity, and which is complex. So we are going for a one simple equation that C is equal to Q by V. Hey sir, yes dear. So actually C is equal to Q by V. It is easy. Why it is easy? Because the dimension formula available into ampere. So too easily I can say, too easily I can say for the charge Q, I can write A1 T1 ampere and the time, okay, in form of second. For the voltage, now it's time to remember this directly. I give you one hint here, for the voltage, remember directly MLTA. Yes, okay. MLTA 1, 2, 3, 1. The initial two are the plus and the after two are the minus. Okay, just keep in mind. Remember this. It is makes a many of the dimension formula easy. Okay, so from here I can say the final answer is M minus 1 L minus 2. For the T upper side I can say T becomes 4 and A becomes 2. So M minus 1 L minus 2 T4 and A2. So maybe option B. Yes beta, option B is the perfect answer. So option B is our perfect answer. That's fine here. 1.82%. That's great. That's great, yeah. Okay, another MCQ. Dear, can you understand all the MCQ concept properly? If yes, then just give your favorite emoji in the comment section, so I can also understand. I can realize that all the students can understand properly. And go ahead for the session. Hello. Okay, perfect. Oh, sir, our favorite emoji is also burger. That's great. Yeah, that's great. Okay, so let's begin here. A 900 picofarad capacitor is a charged by 100-volt battery. So, if you are going to see this data, just remember that is two MCQ. That is actually two MCQ, or we can say two important sum over there in one example and one in exercise. And it is not just for only board exam, also it is important for your NEET exam, for your good set exam. So just break this data and try to understand in a very simple language. Initially they provide 900 picofarad capacitance. So the value of capacitance C is equal to 900 picofarad. Okay sir, we continue. And it is charged by a 100-volt battery. So V is equal to 100 volt. Okay sir, perfect, go ahead. The capacitor is disconnected from the battery and connected by another another uncharged 900 picofarad capacitor. So this sentence matter a lot. It is matter a lot here. So what they actually want to say, initially there is a one capacitor, okay sir, and it is connected with a one battery, okay sir, no issue. And what I can say, during this time the total charge, the amount of charge available on capacitor Q, okay, no issue, which is equal to, I can find out, but no need, I give you one small trick. So actually the value of Q is equal to actually C is equal to Q by V. So now I can say V is equal to C into V, perfect. But here just remember one equation, the amount of energy stored, yes, as a potential energy, as a electrical energy, actually it is an electrical energy. So amount of electrical energy stored in the capacitor, we can say U is equal to 1/2 CV square. But to solve this question easily, remember to use the equation energy stored is equal to Q square by 2C. It's help you to complete this particular MCQ in a very easy matter. Okay, so be continued here. After that what say, okay, so they said just connected with the battery, connected by another charge capacitor. Okay, so disconnect this capacitor from the battery. Okay, then we are going to connect this capacitor with another capacitor, and the main thing is the value of capacitor are the same. So the initial capacitor has the capacitance of same, and the new capacitor has also the capacitance of same. So both the capacitor have the same value. So by that I can say half of the charge, yes dear, just listen carefully, half of the charge available on the initial capacitor, which is going to pass on the another capacitor. Yes sir, no issue, we can understand very properly. And the reason is the value of both capacitor are the same. So in the new condition, I can say the initial capacitor has the new charge of q by 2, and the new capacitor which we are going to just connect in the circuit has also now the charge is equal to q by 2. So exactly charge is going to be distributed between two capacitor. Now what they ask, how much electrostatic energy is lost in the process. Okay, just think about what they ask, total amount of energy loss. So for that we have to find out how much amount of energy still available in this system. Okay, so now I can say the energy available for the very first capacitor. Okay, so new energy in a very first capacitor, what can I say or what can I say here, the amount of charge q is going to be half. Okay, so if the amount of charge is half, then I can say q by 2 has square, so 2 square becomes 4. So if the total part is going to be divided by 4, so I can say the amount of energy is fourth of the initial energy. Yes sir, it is fourth of the initial energy. So actual new energy on a very first capacitor is equal to u by 4. It is fourth of the initial energy. Similarly dear, I can say that on another capacitor also all the given data are same, the amount of capacitance is same, the value of charge is same, so there also energy, the energy is u by 4. So now the new the new energy of the system is equal to, first has whatever amount, second is whatever amount, but I can say u by 4 plus u by 4, so it becomes u by 2. Okay sir, and finally, so we have initially the amount of u. Perfect sir, we have initially the amount of u, and at the end of the process, the amount of energy becomes u by 2. So where is there another u by 2? Yes, where is there another u by 2? So we can say that u by 2 is energy lost in this process. Also you can say in the resistance loss. Yes dear, yes, perfect sir. So finally answer is u by 2. But what we have to do, sir, we have to find out exact value. So now it's for your homework. Just find out the value of C by 1/2 CV square, or you can say by Q square by 2C, and it's a value of U. Yes, energy stored. And then your answer, that energy loss, yes, the energy loss is equal to the total amount of initial energy divided by 2. And if they are going to ask that energy of particular capacitor, yes, energy of particular capacitor, then just you have to divide that energy U divided by 4. You have to divide that initial energy just by 4. Perfect, yeah. Sorry, how much of you students can understand this particular concept very clearly? Yeah. Okay, just mention in comment box once. Then we are going for another MCQ. Hello. Okay dear, just submit your response. Once, then we are going for another MCQ. Yes, perfect dear. Aarti Mehta ji, Paresh Maheshwari, perfect dear. Complete. Hello dear, hello. Can we get the recording of this lecture? Dear, this lecture is currently live streaming on the YouTube. So whenever you are free, you can see this lecture in PW Gujarati live section. Okay, perfect. Chaliye, great. So move ahead. Next MCQ. It is too easy MCQ. It is actually too easy MCQ dear, and you cannot believe, but it's PYQ. Just read the given data. 3 capacitor of the capacitance 2 microfarad, 3 microfarad, 4 microfarad are connected in parallel. So it easy. Why we can say easy? For the parallel connection of the capacitor, we can say the equivalent capacitance C is equal to just sum of all the capacitor available in the circuit. So I can say the equation for the equivalent capacitance, and equivalent capacitance is equal to, so there is total three different capacitance. So C1 plus C2 plus C3. So I can say 2, 3, 5, 4, 9. So final answer is equal to 9 microfarad. Maybe there is some type of printing mistake. So just say to avoid these things. Our final answer in microfarad. Our final answer in microfarad. Okay, sir. No worry. B continue. Surely. Next MCQ. Next MCQ. Let's begin. Let's begin. Option given below, whose resistivity decrease with the increase in temperature. It is definitely a good conceptual MCQ here. It's definitely a very good conceptual MCQ. So very first, what we have to think, just keep in mind very simple things. Whenever there is a metal, also we can say conductor, yes, for the metal, or we can say for the conductor, if we are going to improve the, or increase the temperature, the resistance of that metal, the resistance of that conductor going to increase. So here I can say, for the metal, yes, for the metal, if the temperature is increased, then the resistance is increased. Due to the resistance, or I can say due to the resistivity, the resistance is also improved. Next we can say the conductivity is going to be decreased, and so we can say the conductance is going to be decreased, sir. That's fine here, that's fine. But for the metal, for the conductor, okay, now next move ahead for the semiconductor. So what we can say, totally different, totally inverse property the semiconductor has. So now if we are going to improve or increase the temperature of semiconductor, we can say the resistance is going to decrease, the resistivity is going to decrease, the conductivity is going to increase, and the conductance is also going to increase. So what is demand? Whose resistivity, okay, so just focus on the resistivity, yes sir, whose resistivity decrease with the increase in temperature. So we can say whenever there is improvement or increase in the value of temperature, the resistivity is decreased for the semiconductor. Okay, so option B is the perfect answer. Okay, yes sir, option B is the perfect answer. English is easier than Gujarati. अरे भाई साहब, great यार, वाह भाई वाह. चलो आगे बढ़िए छे. So next आना પછી. Okay, so next question here. Next question, it is easy. Just you have to remember the formula regarding this concept. So try once, then I am going to describe this concept. It's easy. Try once. Try once. Hello. Hello. If there is some type of confusion, if there is some of the questions are in your mind, please feel to ask in the comment section. I try my best to deliver a proper solution for that question. Okay dear. Okay, so great. Check the leaderboard. Okay, give me some time, my dear. After 5 or 10 more MCQ, we are going to check for the leaderboard. Okay, sir, chemistry planning, yes dear. If there is some planning for the chemistry subject, also you get the notification by the PW Gujarati YouTube channel. Do not worry for that things. Okay, okay, so let's continue. Magnetic field intensity at any point on the axis of a very long wire. So read properly. The magnetic field intensity, it means the value of our B, yes sir, intensity at any point. But where this point stand? At any point on the axis of very long wire. So by the Biot-Savart, what we can say? Okay, so there is a one infinite wire we have, yes sir, no issue. For that infinite wire, any of the point at the perpendicular distance of r, and the value of magnitude B, which we can say mu naught I divided by 2 pi r. But in this question they are particular ask for the point available on the axis of the wire. So for that point, just assume that point as a P. So for that point, the value of B, the value of magnetic field becomes 0. So what is the reason for that things? Yes, Hana, we have to understand the proper concept. So reason behind this, we can say the Biot-Savart formula. So what is Biot-Savart formula? So magnetic field, or we can say the small magnetic field, dB, or entire B. Okay, so B is equal to mu naught upon 4 pi, no worry, IDL, or we can say L, divided by r square into sine theta, and it is theta. It is an angle between the direction of that point and the current flow from that wire. And here we can say, whenever our point stands, it has a direction in the x-axis, and also the current is going to flow in a x-axis. So finally IDL has the direction similar to the direction of r. So now here we can say the angle between IDL r becomes 0. So sine 0 has the value of 0, and because of that we can say the amount of magnetic field is 0. Perfect here. So it's an easy concept. We can say the answer option D is the perfect answer. That's fine. But remember, if they ask for any point perpendicular to that wire at a distance of r, we have to use this equation, right? And I can say also that B has the value inversely proportional with the distance available. Okay, next. Very simple question. It is also a very simple question. Okay, perfect. So next, two long and parallel straight wire A and B carrying the current of 8 ampere and 5 ampere in the same direction. So here dear, one key point is available. What is they actually say? The same direction of the current. Yes, okay. And separated by a distance of 4 centimeter. Estimate the force on a 20 centimeter section of a wire A. Let's begin. And if there is some type of fear that we are actually cannot remember the equation properly, so I give you one suggestion here. In every morning and in every night, you have to plan for 30 minutes. What we have to do in that available 30 minutes, just start from the chapter number 1, write down all the important equation, just revise that concept in your mind and paste that formula in that blank sheet. Start from the initial chapter and end on your last chapter, 14th chapter. That final equation is Ni square is equal to Ne into Nh. Yes, for the semiconductor, or we can say for the doped semiconductor. So initially you think that no sir, it's take a long time, it is actually a wasting of time, but no, you are think in a wrong direction. Actually it's too much important for your upcoming exam. If you can properly revise your equation, if you can properly remember your equation, it going to help for completing your MCQ in proper time. It going to helps you for completing all the sums perfectly during the exam. So equations are, if you are going to complete all the equations properly, it's definitely going to help for your upcoming exam dear. Okay, so let's begin for the given data. They say for a two parallel wire. Okay, so there is two parallel wire are available, and the amount of current flowing from that for a very first initial wire IA is equal to 8 ampere, and another wire B, I can say IB has the value of 5 ampere. Also they divide the separation distance between two wire and given as a 4 centimeter. So it is data we are taking as a R is equal to 4 centimeter, and the estimate the force on a 20 centimeter section. So they given a length for any of the wire, but here they provide for a particular wire A. Do not worry. If they provide for another wire, no worry. All the things are same. By the Newton's third law, the amount of force applied by the B on the A, which is equal to the force applied by A on the B, both has the value are same, but the direction are opposite. Okay, so just here we have to remember that equation directly, and the force between two charges has the same direction of the current. I can say F is equal to mu naught I1 I2L divided by 2 pi r. Now just put down the value. The value of mu naught is equal to 4 pi into 10 raised to minus 7. The initial wire has the current of 8 ampere. The another wire has the current of 5 ampere. The distance, it is the distance for which you are going to find your final force. Okay, so it is the length, and length is given as a 20 centimeters, so you have to convert in a meter. So finally 0.2 meter divided by 4 pi, and r is the parallel distance between two wire. So I can say the value of r is equal to 4 centimeters. So 4 centimeter becomes minus 2, so it's converted into meter. And by the normal mathematics, so what we can say, 2 pi cancel 4 pi by the 2 na 8 ka kaata by the 2 sir. So 5 into 2, 2. So 2 becomes 2, 4. 4 into 5, 20. 20 into 2. So becomes 4. Okay. So finally there is a 4. Okay. Into 10 raised to minus 2 upper side. So minus 5. And the force F in Newton. So 4 into 10 raised to 4 into 10 raised to minus 5 Newton. Option B is the perfect answer. Yes. Option B is the perfect answer. Now there is a one very simple concept available there. It's called Ampere law. It's called Ampere law. If the direction of current similar in the both wire, there is attractive force, and if the direction of current opposite in the both direction, we can say there is a repulsive force available between that two wires. Okay, so please keep in your mind, because they are just going to add. Okay, so here by the comma they provide if it is force is attractive or repulsive. So it is too simple formula. Same direction attractive force, opposite direction repulsive force. Okay sir, we can handle it, we can handle it. So just request you to focus on the session. Yes, there is a multiple reason are available to left this session, to left the preparation and just going for one bindas mood. But no, it is your important time for upcoming exam. So just focus on your goal and continue the session. We are going to for a oh sir, oh nice dear. Actually it's a very good concept, and someone gives me chance to create some MCQ for the upcoming papers. I will also I definitely ask from this particular concept. I like this concept. Yeah, surely. Let's get ready. Let's get ready. Hello. Okay, let's begin. Try once, then we are going to complete the full concept behind this question. Sir, Hindi bolo, no issue, we can understand. Yes dear, but I have some type of fear for the Hindi language. I have some type of fear. I don't know, but very soon I will try to resolve that fear. Okay, so let's begin. What is the correct relation between permeability of a ferromagnetic material mu and the permeability of a free space mu naught? Okay, so generally start this type of concept initially with one particular things you are going to learn as XM. Okay, now what is XM exactly? What is exactly XM? So we can say, sir, it is magnetic susceptibility. What we can say? It is magnetic susceptibility. Yes, perfect. So start with the initial concept that we have available one dielectric type of element. Okay, sir, perfect. One element is dielectric. For the magnetism, we can say one diamagnetic. Okay, sir, one is diamagnetic. Okay, the another is a paramagnetic, sir. Okay, perfect. And the last one is the ferromagnetic. So for all this material, just keep in mind that the XM, magnetic susceptibility, yes sir, the value of magnetic susceptibility XM is a negative. I'm sure, yes, XM has the negative value. For the paramagnetic type of material, the XM as the value is positive, and for the ferromagnetic, you can say the value of XM is positive, but very large than the paramagnetic material. So from here we are going to start. So XM is a negative. So I can write down -1 greater than XM greater than 0. Okay, sir, perfect. So we can say the XM has a value between -1 to 0. Okay, perfect. Now for the paramagnetic material, from 0 greater than XM to any of the value. It is not the permittivity, dear. It is not the permittivity of any medium. It is just a one number that has not perfect value, but just a number. Just a number indicate that I am a small number but positive number. That's fine. So 0 greater than XM greater than epsilon. And for the ferromagnetic, we can say XM has a very large value, so it is greater or greater than 1. Okay, XM is very greater or greater than 1. So it is for the XM, your first concept. Okay, now from the XM we are going for mu r. Sir, mu r, yes, relative relative permeability. Yes sir. Okay, perfect. So what is mu r? Mu r is equal to 1 plus xm. Mu r is equal to 1 plus xm. How to remember same things after a long time? We know that value of mu r is equal to mu divided by mu naught, and which is equal to 1 plus xm. Okay, so always remember in this format. So by the long time you have no confusion, regarding is the mu r is equal to 1 plus xm, or we can say xm is equal to 1 plus mu r. It's create a huge confusion during your exam time. And just for that, I give you one suggestion to remember that the value of mu r, initially start from here. Yes sir, the value of mu r is equal to mu divided by mu naught, which is equal to 1 plus mu r. That's fine. Yes, it's make easy formula. Okay sir, perfect. Now we have to go for mu r and need to adjust one both side, or we can say every side. Okay, so minus 1 has plus 1, just add a plus 1 in each and every step. Xm has plus 1, also 0 has plus 1. Okay, similar here, 0 plus 1, we can say xm plus 1, we can say epsilon plus 1, and here I can say 1 plus 1 greater than xm plus 1. So from here 1 plus 1 minus becomes 0, xm plus 1 is equal to mu r less than the 1. Okay, perfect sir. Next, xm plus 1 becomes mu r and less than epsilon plus 1, and for the ferromagnetic I can say 1 plus 1 becomes 2. If something is greater than 2, yes, if the value is greater than 2, definitely I can say it is greater than 1. So again I repeat, 1 greater or greater than, okay sorry, less or less than mu r. Okay, please forgot the small mistake are over them. Sir, mu r has the value less than 1. Yes, what is actually mu r? Mu r is equal to mu upon mu naught, has the value less than 1. So for the diamagnetic element I can say value of mu is less than mu naught. Okay, so here again, what is mu upon mu naught? It is the value of mu r, it is epsilon plus 1, so I can say epsilon plus 1. Sorry, okay, it is just any of the positive value, or from here I can say 1 less than mu r. Okay sir, so 1 is less than mu upon mu naught, so the value of mu naught is less than mu. So for the diamagnetic we can say mu is less than mu naught. For the paramagnetic we can say mu naught is less than mu. Okay, fine. And what they actually asked here, correct relation between permeability. Okay, so permeability is mu of the ferromagnetic material and the permeability of a free space. Okay, so for the ferromagnetic, I can say 1 less or less than mu r has a value of mu upon mu naught. So finally the mu naught is less or less than mu. It is perfect answer for your ferromagnetic element. So mu naught, yes sir, mu naught less or less than mu, option C is the correct answer. So it is not just only a one MCQ here. What I try over here, I try to cover entire concept. So maybe there is a 9 to 12 MCQ on your one board. On your single slide, there is 9 to 12 MCQ. If they are asking about the value of xm, you can do properly. If they are asking about just the relation between value of mu and mu naught, you can do it properly. If they are asking for the exact value about mu r, also you can do from here. Okay, so it is not just a one MCQ, it is entire concept related to xm for any of the element here. Okay, so option C is the perfect answer. That's fine. 87.5% students are going to be correct. Okay, which is the incorrect unit for a self inductance? Okay, it's good, really a good question here. Sorry, what is actually self inductance? Similarly, mutual inductance, or we can say just inductor. So initially its concept start as a flux for any of the coil which is proportional to the current, okay, from the same coil or the another coil, and by this proportionality constant I can say phi is equal to Li. So L enter as a one constant, like similar to resistance, similar to capacitance, there is a one constant, and we can say the main equation phi is equal to Li. Now if we are going to derivate this by the time, so d phi by dt final sir is equal to L, a constant, di by dt, and by this I can say it is the equation of EMF. Yes beta, EMF by the Faraday law, we can say it's epsilon and minus L di by dt. So there is multiple unit available for the induction. You can say self inductance, just only inductor, or for the mutual inductance. Multiple available units are there. But from here, what they ask, which one is incorrect unit? Okay. So if we know all the units properly, then and then this MCQ, we are going to correct. Okay, perfect. So start. Initially they give joule upon ampere square, volt second upon ampere, Weber upon ampere, Newton meter upon ampere. So let's begin. From here I can say the unit of L is equal to the unit of Weber, flux becomes Weber upon ampere. Also I can say L. What is Weber? Phi is equal to A into B. So exact meaning of Weber as the Tesla in a meter square. So Tesla meter square divided by ampere. Okay sir, perfect. So initially Weber upon ampere, yes sir, perfect. Weber upon ampere available. Okay, so from here, from this sequence I can say the unit of L is equal to epsilon. Epsilon is volt. Time, okay, time available in second, so upper side volt into second divided by unit of current ampere. So volt second upon ampere, volt second upon ampere. Okay, both are correct, but still there is something remaining. One confusion between joule upon ampere square or just Newton meter upon ampere. So we can say there is one more equation for the energy stored in the inductor. U is equal to 1/2 Li square, which make your process easy. So for the energy I can say unit is joule. Okay sir. Next, for the inductance I have to find out the exact unit, and for the current the exact unit is ampere, but current as square, so ampere square also. So now I can say the L has another unit of joule upon ampere square. So option A is also correct, and finally I can say the option D is incorrect. Finally I can say option D is the incorrect answer. Done here, easy question. Be continue for the next question. Okay, a pair of adjacent coil has a mutual inductance given. The current in a one coil change from 0 to 20 ampere in 0.5 second. The induced EMF in the other coil is, okay. So what I going to say, by the data it's look like a complex MCQ, but if you try to remember the exact concept, the exact equation which are attached with this question, you can definitely solve this MCQ. It is so easy MCQ. Just try to remember exact equation which is suitable with this concept. Try once dear. Try once, we can do here. Chali, we can do. Try once. Perfect. Sir, where are you? Yes dear, I am here. Just a 1 minute. I just update your comments. Check the leaderboard. Okay, after 5 to 7 MCQ we are going to check. Just try this MCQ first. Okay sir, how to revise properly? My one chapter can take 2 to 3 hours, and 18 to 19 days before the exam. Okay, so dear, on the last 2 to 3 days available for your exam, I just want to say, try to prepare by a rhythmical way. Target initially all the sums available in your syllabus for the physics. Then try for PYQ section. Target that PYQ for particular 6 to 8 hours and complete all the PYQ questions MCQ. Then just try to write down one paper minimum one paper. Try to write down in a time of 3 p.m. to 6 p.m. right? Okay, so in last 3 days try to follow this. Maybe it helps you to improve your result. Okay, chali, perfectly. A pair of adjacent coil has a mutual inductance. Okay, so they give the value of mutual inductance. We can say the value of M is equal to 1.5 Henry. Okay, next continue. If the current in a one coil changes from 0 to 20 ampere, so actually they give the change of current. Okay, and I just write down the final value, that 20 ampere. Okay, change of current in just 5 seconds, so change in time is equal to 0.5 second. Okay, and I have to find out the induced EMF. So for the EMF, I can say that epsilon is equal to M into delta I by delta T. It is nothing but direct question from your NCRT exercise. Okay, so it's easy. So value of EMF epsilon is equal to M. M has the value of 1.5, delta has the value of 20, and the time is 0.5. So here I can say 0.5 becomes 1/2, 1/2 going to upper side, 1.5 multiplied by 2 becomes 3, 3 into 20 becomes 60 volt. Is it available in the given data? Yes sir, yes sir, there is 60 volt is available. So option A is the perfect answer. Hana, it's easy MCQ or not, dear? Perfect, easy. 83% of the students are going to click right question, right answer. Chaliye, nice. B continue. Great. In a AC circuit having only inductor, okay, only inductor, I is connected to V. Okay, then, so dear, there is totally three different circuit are available in our syllabus. So initially I can say only resistance with AC supply, only inductor with AC supply, only capacitor with AC supply. Okay, so it is two are different type of, sorry, three are the different type of circuit, as we can say as the initial combination. Okay, then we are going to connect all the three things in just a single supply. So it's called LCR, AC series circuit. LCR, AC series circuit. Also we can apply a double combination, dual combination. There is only just inductor and capacitor, only capacitor and resistance, only inductor and resistance. But here our question is too simple, but we need to remember the phasor diagram properly. So let's begin with a concept. If there is only resistance, yes dear, if there is only resistance is connected with the AC, then I can say phasor diagram in the direction of current, in the direction of current, similarly the direction of voltage for resistance. Okay, so the phase difference between I and VR becomes 0. The phase difference between I and VR becomes 0 for only resistance. Okay sir, perfect. So if there is only inductor available into the AC circuit, okay sir, no issue. If there is only inductor available in the AC circuit, we can say a phase difference of pi by 2. Yes, a phase difference of 90 degree between I and VL, between I and VL. So I just give you one hint. For the inductor, remember to create L. Sorry, yes dear. For the inductor, you have to remember, you have to keep in mind that I have to create L. For the inductor, I is always in the X direction. Yes sir, I is always in the X direction. So I have to write down VL in the Y direction. An angle of 90 between I and VL. Okay, so they ask for the AC circuit having only inductor. I is connected to the V. Then, so what can I say? The angle, okay, the angle of VL is greater than I, and how much the value? It's just a pi by 2. So I can say voltage, yes, voltage has the phase pi by 2 more than the current, or I can say that inversely sentence also. Just read the given data, given available options. Current lags behind the voltage by pi by 2. Perfect dear. Current, it is lag by the pi by 2 phase with the voltage. Perfect sir, our initial sentence is perfect, it is completely suitable with the reality. Okay, the current lead, no, current is not leading, actually voltage is leading sir. Perfect. Current lead, no sir, no. Current lag the voltage by pi, no, by the pi by 2. So all other options available are the wrong options. Okay, so next continue. They provide a light bulb rated. Okay, so whenever they are provide the rating of the bulb, they provide two value. They provide the value of power and the value of voltage. So the value of power of the bulb is equal to 100 watt, and the voltage given is a 220 volt. So just take a pause. What is actual meaning of this rating? This rating indicate that if you provide the 220 voltage value to the bulb, it is give you the light with the maximum intensity. Yes, so we can say if we provide just 110 voltage, yes, it's give you light, but not the maximum intensity. There is some type of decrease in your final intensity. So at a 220 voltage, it gives you a full light. So it's called the exact value of rating, exact meaning of rating, and the resistance of the bulb. So there is a famous equation, we can say power P is equal to V into I, power P is equal to I square into R, and power P is equal to V square by R. So by just last equation, I can say the power is equal to V square by R. So if I have to find out the value of R, then just divide the V square by P. The value of V is equal to 220 multiplied by 220 by the value of power 100, 0, 0 cancel, 22 multiplied by 22. The final answer is 484. Easy concept. B continue. A radio can tune into any station in the 7.5 megahertz to 12 megahertz. So what they say, they actually give the frequency range. Yes, they actually give the frequency range for the radio, and the minimum frequency f1, okay, 7.5, and the maximum frequency f2 is equal to 12 megahertz. What is the corresponding wavelength band? Okay, so they are asking for the range of wavelength, and the formula is too simple. You all are know, sir, we know from our childhood, that the value of f is equal to c upon lambda. So for the initial case, lambda 1 is equal to c upon f1. The value of c, it is going to, yes, it is going to, so simple, sir, it is a value which is known by the entire nation. That value of c is equal to 3 into 10 raised to 8, and the value of f1 is equal to 7.5 into 10 raised to 6 because of mega. So if 10 raised to 8 divided by 10 raised to 6 becomes 10 raised to 2. So 3 into 10 raised to 2 divided by 7.5. Now I going to cut 7.5 by the 3. I can say it is 1.25 multiply by 10 raised to 2. So it is, we can say 100 divided by 2.5. So I can say it is 1000 divided by 25, and answer is 40 meter. Okay, so 40 available. Yes, dear, 40 is available in just option B. So try another by yourself. It is so easy. Same formula, f2 is equal to c upon lambda 2. So lambda 2 is equal to c divided by f2. You can do the things easily. So move ahead. Okay, another too simple but demanding concept. They ask two type of question from the telescope. Okay, generally they are going to ask here two type of question from the telescope. What they ask, they give you the wavelength. Oh, sorry, no, beta. They give you the focal length. It's not a wavelength. In last question, it is wavelength. Okay. So in the actually concept of telescope, they provide you the two value of wavelength. Okay, the wavelength for eyepiece, yes sir, and the wavelength for the objective lens. By that two value, what we can find out? We can find out first the magnitude. Yes sir, it's not magnitude here, it's magnification. We can find out the magnification. Yes, general formula, m is equal to fo divided by fe. And they can ask the tube length. What they can ask? They can ask a tube length, and tube length L, it is so simple, just sum of that two value. So from here I can say mainly two concept, and both the concept are so easy and demanding in your last PYQ. Just check out here, there is 3 to 5 MCQ over there. Okay, so for the telescope, yes, they provide the objective lens has the focal length f O, okay, 132, and the eyepiece has the focal length fe is equal to 6 centimeter. The magnifying power, okay, so if they ask for the magnifying power, just divided fo by fe. So I can say the value 132 divided by 6 cancel 13 sub kya hoga, 6 to 12 becomes 1, again 12, 22. So actually I get the value of magnification as a 22. But another concept I am going to add over here. If they ask for the tube length, just L is equal to FO plus FE. It is more easy. So I can say the value of FO is equal to 132 centimeter, and the value of is equal to FE is equal to 6 centimeter. So answer is a 138 centimeter. Perfect, sir. We continue for the next MCQ. Unpolarized light, yes dear, unpolarized light incident on a Polaroid. So it is too simple concept of a polarization. It is too simple concept of the polarization from the chapter. Sir, the chapter is too much difficult, very complex concept, but this MCQ is too easy. Just remember it directly. So whenever there is unpolarized light, yes, is passing through the Polaroid, is passing through the Polaroid. What we get? We get the polarized, we get the polarized light over there. Yes dear, perfect. And remember directly, if the initial intensity of the light is I, then the intensity after polarization becomes half of that, becomes the half of that. Okay, so keep in your mind directly. And after that, we can say one law we are going to study for as a Malus law. Okay, yes, perfect sir. And if there is another Polaroid at an angle of theta, at angle of theta with the initial angle, okay, so there I can say the new intensity, yes, after the another Polaroid, the intensity, the final intensity I, okay, it's okay. So I is equal to, who is initial? I dash. So I dash into cos theta or the cos square theta, I dash into cos square theta, sir. Okay, so here answer is too simple. By the polarization, initially we can say whatever the intensity we get after the polarization, it is half of the initial velocity. So option C is the perfect, option C is the perfect here. Okay, B continue for the next question. Which phenomena cannot explain by the wave theory? So what is wave theory? Wave theory, it is we can say chapter number 10, chapter number 10 of the syllabus. So in chapter number 9 we are going to study ray optics. We consider as we consider the light as a straight following path. Okay, so by that I can say, we can understand what is reflection, what is refraction, what is total internal reflection. But which phenomena cannot be explained by the wave theory? So in chapter number 10, by the wave theory, we are going to learn about interference, we are going to learn about the diffraction, we are going to learn about the polarization, but we cannot learn the things of photoelectric effect with the theory of wave. Yes sir, yes, we have to accept, that light is a particle things, light is a particle things. Okay sir, the corpuscular theory explained by the Newton, which help over here to understand the photoelectric effect, also some of the explanation given by the Einstein. Yes sir, perfect. So it is the part of chapter number 11. Hope you understand properly, hope you understand properly. The photoelectric cutoff voltage in any certain experiment, Chali, it is too easy MCQ. Just try to remember the equation. Okay, try to remember the equation. Dear, I need your response in the comment section. I need your response in the comment section. Yes, that you can understand all the concept properly or not, because your response in the comment section, it is one type of strength for each and every teacher, that yes, our students can understand all the things very properly. So it is give a one energy boost to ourselves also, right? Okay, perfect. Yes, fine. How much students are continue watching these things? 44. Okay, fine dear, fine. It's a great response. Thank you all of you, thank you. No dear, you do not need to write out the given data. Just get the PDF from PW Gujarati WhatsApp channel. Okay, it is too easy dear. Just join the PW Gujarati WhatsApp channel. After the session, we provide entire PDF of the session over there. Okay, so don't write down the total data. Just try to calculate the given MCQ or the sum dear. Okay. Okay, perfect. Okay, so over here, what they say, the photoelectric cutoff voltage. Okay, so actually cutoff voltage also we know as a V naught. Okay sir, fine. So value of cutoff voltage is equal to V naught. Also we can say stopping potential in the linear practical. Okay, and what is the maximum kinetic energy of a photoelectron emitted? So they ask for the kinetic energy, and we know it is so simple formula that maximum kinetic energy is equal to EV naught. Now just check out the option. Answer are available in a joule. So put the value of E in joule, 1.6 into 10 raised to minus 19, and the value of cutoff voltage as a 2 volt. So finally I can say 3.2 into 10 raised to minus 19 joule. 3.2 into 10 raised to minus 19. Option B is the perfect. Who is perfect? Option B is the perfect, sir. Okay, that's fine. 85% बच्चों का आंसर सही है. चलिए, so just look at the leaderboard. Total 30 students are participating. That's fine यार, है ना? I am happy. That's good यार. Professional housekeeping. अरे भाई साहब, नीतल पटेल, नीता पटेल, केविया, माहिरा, मानु देसाई, पार्थ पंड्या, Vedits, Arthur, Unilingo. I don't know but how to speak your name properly. Just give me some type of hint in the comment section. Sivang Manavar Mina Naturalipa. Mina Natural. क्या लिखा है बेटा? हाँ चलिए, ओके, बी कंटिन्यू यार. फाइन फाइन, सॉरी फॉर दैट थिंग्स, सॉरी फॉर इम्प्रॉपर प्रोनाउंसमेंट. चलो स्टार्ट. For the next MCQ, which condition is satisfied for photoelectric effect in metal given below? Sir, energy of incidence photon is lesser than work function. So if the initial energy or the emitted energy, no sir, it's not an emitted, it's an incident photon energy. So if the incident energy is less than the work function, there is no emission of electron from any of the metal. So first option is definitely wrong. Next, frequency of the incidence light. Okay, so frequency, incident frequency as a f is greater than the threshold frequency. So what they say, f has the value more than the f naught. So definitely we can say if the f is higher, then the incident energy is also higher than the work function. So finally we get the photoelectric effect. Yes sir, perfect. So I can say option B is the perfect answer. Option B is the perfect answer. Move ahead. Next question. In our next question, monochromatic light of a frequency, so they provide the value of f is produced by a laser, the power emitted. So they give also the value of power emitted, how many photons per second. So they ask how many photons, the number of photons per second, okay, on an average are emitted by the sources. So just remember two important formula. The intensity I has the value equal to energy divided by time into area. So very first, I is equal to energy divided by area into time, and the amount of energy for a single photon is equal to hf. So for the numbers of photon, nhf divided by 80. It is generally used in your old syllabus and it is important formula in the old syllabus, but for our syllabus we have to complete for the power. So what is power? Power P is equal to energy divided by time. Okay, so for a singular photon, energy is equal to hf. So available numbers of photon, total energy is equal to nhf divided by time t. So they ask for numbers of photon per unit second. I get as the P divided by HF. Now just put the value of power given as a 2 into 10 raised to minus 3. The value of Planck constant 6.625 into 10 raised to minus 34. The value of frequency also given. So by the normal mathematical calculation, you can get the perfect answer. And the answer is option D wala. Option D. Next question. Okay. So next. Perfect here. So in the next ratio of a radius of a third and second orbit, what they provide, they give the numbers. Radius of a third, so n is equal to 3, and the radius of a second, so n is equal to 2. Orbits of the hydrogen. So please check here for hydrogen. If they ask for the lithium, you have to change the value of Z. You have to change the value of Z. Okay, now just remember the equation for radius. Equation for radius, not in nucleus, for the atoms, and both have the different formula. So keep in mind properly. For the atoms, yes sir, for the atoms, I can say the full equation of R as n square h square epsilon naught divided by pi z is square m sir. If the z is same, yes sir, the value of E is same, the value of mass is same, the value of h, value of epsilon naught, all are the same, and I can say R is directly proportional to the n square. So radius for the third, so R for the third orbit, the radius for the second, so R for the second orbit. I can say that and the value of 3 and the value of 2 has the square. 9 square becomes 3 square becomes 9, 2 square becomes 4. So 9 by 4 is the perfect answer. Option D is the perfect. B, continue. The another MCQ. The another MCQ, potential energy of an electron first excited state in the hydrogen atoms. So I just say to remember all the stages with their available energies. Okay, so very first initial stage, n is equal to 1. The excited state, the first excited state, n is equal to 2, n is equal to 3, n is equal to 4. Okay, so in a base state, for the first orbit, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. First excited state, second, and it is third. So initial orbit has the energy of minus 13.6 electron volt. The n is equal to 2. Okay, so second orbit, or I can say first excited state, has the energy of minus 3.4 electron volt, minus 1.51 electron volt, minus 0.85 electron volt. So for the energy of an electron in a first excited state, so first has 1, excited had was 1, so the value of n becomes 2, and whenever n becomes 2, the energy available is minus 3.4 electron volt. Directly keep this question directly. Okay, potential energy of an electron. Oh dear, sorry, they ask for the potential energy of an electron. Okay, no issue, sir. I think it is same. Okay, perfect. Yeah, chaliye, going ahead. So what is success? It is not the things you get in early morning or late night. It is the things you get by your efforts. So at which intensity you apply the efforts, the way you get success, the level of success you decide by your efforts. So just keep in mind, success, it is not just a story of a one day. It is not just a story of a one day. It is the result of your 2 years effort. In reality, I can say it is the result of your 12 years of effort. From initial standard, from the first standard, you are going to start improve yourself. By the year you make some type of improvement in yourself, and after this 12 year, it is time to prove yourself. It's time to prove yourself, right? So keep in mind, the success definitely we can achieve, but needs some more efforts in the last some days available. Okay, so next year, complete the nuclear fission equation given below. So I can say the total amount of nucleon is 92, here just a 38, and upper side 236 and 94. So what we can say 92. Okay, so for this side 92 minus 38, we get 92 becomes 8, 12, 4, 8, 3, 5, 54. So on the bottom side we need the value of z. Yes, the value of z is a 44. Two options are available, option C and option D. For the value of A, 236, 94. So 236 minus 94 becomes the 2. 23 minus 9, it means I can say it is 9 cancel out, so 14. So 142. I need 142. So 142 into 1 becomes 2. So 140 plus 2, 142. So option C is suitable. In option D, we get 140 plus 3 into 1 becomes 143. And it is not suitable with the given data. Okay, fine. Next, when atomic mass number is increased, the nuclear density. So remember dear, nuclear density, it is something that need to keep in mind. The equation of rho at the nuclear level is equal to 3m divided by 4 pi r naught cube. And what is r naught? It is a constant, has the value of 1.1 Fermi or 1.2 Fermi. And by this data, okay, what is m? M is the value of mass of proton, dear, fixed value 1.67 10 raised to minus 27. So by that I can get the value of density at a nuclear level for any of the nucleus. Okay, so the value of rho is equal to 2.3 into 10 raised to 17 kilogram by meter cube. Okay, so the value of rho, it is not depends on the value of A, on the total nucleon, or we can say on the numbers of proton and electron. So Here I can say it is increase, no. It is decrease, no. Remain constant, yes. The density is remain constant at the nuclear level. Perfect, dear. Okay, so move on the next question. When a forward bias is applied, what is going to happen? What is going to happen when the forward bias is applied? So for the PN junction diode, we can say if we connect the positive side of a battery with the P and the negative side with the N junction, okay sir, finally we can say PN junction in forward bias condition. So for the forward bias condition, raise in the potential barrier, no, forward bias is going to decrease the potential barrier. So the value of current flowing from the conductor is increased from the PN junction diode, it increase. So the raise in the potential barrier, it is the wrong option. Reduce the majority carrier current to 0, no dear. During the forward bias, the value of current which is we can say flow just because of the majority charge carrier, so it becomes 0, no, we can say the sentence is wrong. So next, lower the potential barrier, perfect sir. During the forward bias, the value of potential barrier is decreased, and just because of that, the higher amount of current passing through the PN junction diode. Okay, next, suppose a pure Si crystal, pure it means there is no doping, it is no N type of or it is not P type of, it is pure semiconductor. So whenever they say the pure semiconductor, if it is silicon, if it is germanium, do not worry dear. Suppose a pure silicon crystal has a 5 into 10 raised to 28 atoms prati meter cube. Okay, so per unit volume, it is doped by a 1 ppm, it's parts per million. So what they say, for a 1 million available atoms, we put a 1 doped atoms. Okay sir, chaliye start. It is doped by 1 ppm concentration of pentavalent arsenic. Okay fine, so we doped with the pentavalent, we can say it is N type of semiconductor, and the for the N type of semiconductor, the numbers of electron, okay, per unit volume, Ne is equal to directly total numbers of atoms 5 into 10 raised to 28, we doped or we concentration just given as a 1 parts per million, so it is divided by 10 raised to 6, becomes 5 into 10 raised to 22 numbers of electron in the unit volume. Okay sir, fine. The number of electron density, okay, so we get it perfectly, 5 into 10 raised to 22. But if they ask for the numbers of hole, okay sir, so I can say Ne into Nh is equal to Ni square. Also they provide the value of Ni, so from here you can easily find out the value of Nh. That's fine, be continue. The unit of magnetization, chaliye find here, it's really a good and easy question. Do not combine the 3 units. I again repeat, do not combine the 3 unit. All have the different type of unit. A very first on a board is the magnetization. Second is the value of magnetic pole. Second is the value or unit of a magnetic pole. Yes sir. And the third is magnetic moment. All the 3 are different quantities and all has the unit are different but look like same. Okay, so just try to write down all the 3 quantities. Start with the dipole, okay, dipole moment, magnetic dipole moment. The another is the value of we can say magnetic charge. Yes sir, value of the magnetic charge or the magnetic mole. And the third for the magnetization. Let's start here. Okay, so the SI unit of the magnetization. So actually magnetization M is equal to the available magnetic moment for the unit volume is called as the magnetization. Yes sir, the value of available magnetic moment per the unit volume. So the unit of magnetic moment is equal to, sir, I cannot remind, so just remind the value or the equation of the magnetic momentum. M is equal to I into A. The unit of the current is ampere and the unit of area is equal to meter square divided by the unit of volume. The unit of volume is meter cube, so I say the final answer is ampere divided by meter. Okay, so ampere by meter, option A is the perfect answer. But what I say initially, sir, we have to complete complete the unit for a magnetic moment. I into A has the unit of ampere meter square. That's fine. So ampere meter square, it is not available. Fine. Also make one unit for the magnetic charge, that Qm is equal to m divided by twice L. As I can say, m is equal to twice L into Qm. Perfect, sir. So for the Qm, I can say m divided by twice L. So unit of m is equal to ampere meter square, and the unit of distance between two magnetic charge as a meter. So the final unit for the magnetic pole is equal to unit ampere into meter. It is also not in your given option, so it's good. It's good here. Option A is the perfect answer. I can say option A is the perfect answer. Fine, 100%. Oh yeah, great, 100%. That's great, yeah. Amazing, amazing, yeah. Too happy. Chaliye, fine. Okay, so next, the mutual inductance M21 of a coil 1 with respect to coil 2. So just remember one theory from the chapter number 6. What we learn? We learn one theory as a reciprocity theorem. As a reciprocity theorem with the same axis of two solenoid. Yes, sir, there is two solenoid with the similar axis, and we prove over that in the reciprocity theorem that M21 becomes M12. Both has the same value. And you can apply this fundamental for any of the combination. Okay, dear. So just keep in mind, by the reciprocity theorem, the value of M12, M21 both are the same. So option A is the perfect, is the same as M12 and 21. M12 and 21 both are the same. Both have the same value. That's fine. Easy MCQ. The SI unit of the time rate of change of magnetic flux. So magnetic flux changing by the time, it is nothing but the Faraday equation, and I get the epsilon, and epsilon has the value in volt. The unit is the volt for the epsilon. B continue. Next question, which one the following question is not correct? Okay, so integration BDL mu naught IC mu naught epsilon naught d phi by dt. It is ampere Maxwell equation you get in the chapter number 8 after displacement current. After displacement current, we get that exact formula. Yes, sir. And it is the value for displacement current, and it is our regular current. Okay, yes, sir. Perfect. Integration B into dA. There is something wrong. Integration, closed integration B into dA. It is Gauss law for the magnetic field, and we know for the closed loop it is always 0. Why? Because the magnetic field lines make the closed loop. So amount of lines enter. The similar amount of line exists from the loop. So the final flux is equal to 0. Yes, sir. Perfect. E into dl d phi by dt. Yes, perfect. By the law of Faraday. And E into dA becomes Q upon epsilon naught, the Gaussian law for the electric field. So the wrong equation in the given option is option B. Next question, double convex lines. Okay, dear. So it is maybe easy question. Just you have to remember the main fundamental equation behind this given data. So try by yourself first. Then I'm going to cover. Okay, start the question. Just try to remember lens formula, lens maker's formula for that refractive surface. Yes. Okay, so from this all formula you get the perfect formula which is suitable for the given data. Try once, dear. Chaliye. Okay, so for the double convex lens, sir, for the double convex lens are to be manufactured from a glass of a refractive index 1.55. So they provide the refractive index for the medium of the glass as a 1.55. Perfect, sir. With the both faces of the same radius. So they provide that the radius for the both side are same, but please remember, you have to take the R1 as a positive value and R2 as a negative value. Why? Because both has a different of side. So if radius of curvature for one side is on positive side, we can say in the direction of incident ray. So we take as a positive, and for the another we take it as a negative. So please keep in mind, we have to apply this in the available equation. Okay, with the both faces of the same radius of curvature, what is the radius of curvature required if the focal length is to be 20 centimeter. So in a given data, we can say they give us the value of focal length, and if we have the value of focal length, the equation is so easy. For focal length, I can say 1 upon f is equal to n minus 1. What is n? N is the refractive index for the medium of the lenses. Okay, chaliye fine. So n minus 1 and 1 upon r1 minus 1 upon r2. That's fine. Now apply the value 1 upon f. F is 20 centimeter and the final answer is also in centimeter, so no need to change. F is 20 centimeter value, and n has the value of 1.55 minus 1 upon r1 r2 both are the same, but as I say, if we put the value of r1 as a capital R positive, so similarly you have to put the value of r2 as a r but negative value. Okay, so minus minus becomes plus 1, so 1 upon 20 is equal to 0.55. Okay, 1, okay, minus minus plus, so 1 plus 1 becomes 2 divided by r, and for the value of r I can say 20 multiplied by 1.1, and the final answer is 22 centimeter. Final answer is 22 centimeter. Option C is the perfect answer. Okay, so finally option C is the perfect answer. That's great. 80% of students are going to click the correct answer for the two coherent sources. Okay, for the two coherent sources vibrating in a phase for any arbitrary point. Okay, any arbitrary point whenever the path difference is constructive interference. So for the constructive interference, we know that the path difference is equal to n lambda. It's just a simple equation, just a simple condition. Okay, perfect here. So move ahead. Okay, so there is some type of another questions are available there. So I just put all the questions for your practice. Just try this simple questions from the Wheatstone page. Okay, it is the last question we are going to try today. Start here, and I also provide you 10 to 12 MCQ. 10 to 12 MCQ as a homework MCQ. You get that MCQ in the PDF, and to collect that PDF, what you have to do, just a simple, in a WhatsApp, join PW Gujarati WhatsApp channel. After the session, the link with the PDF available over there too easily, so just click on that link and you get the PDF of the session. Okay, so don't confuse about that, it is so easy process. And before that, try this MCQ. Before that, try this MCQ, dear. Yes, respect that minus. Yes, perfect, dear. Respect that minus, otherwise you are going in a different way, in a complex calculation, because it becomes 0, and from the 0 it becomes infinite. So the electric circuit, electric current passing through a 5 ohm resistance in the following circuit diagram is dash. Okay, so here I can say for the circuit, it is a Wheatstone bridge circuit, sir. The value of R1, R2, R3, R4 are given. So R1, R2, R3, R4. Sir, what if I write down R3 over here and R2 over there? No any issue. Just you have to check the ratio of 2 and 6. Okay, the ratio of 2 and 6 becomes 1 upon 3. Okay, the ratio of 4 and 12, the ratio of 4 and 12 becomes 1 upon 3. So if the ratio, both sides the ratio are same, we can say the Wheatstone bridge in equilibrium condition. And if the Wheatstone bridge in equilibrium condition, the current flowing from this middle wire, we can say it becomes 0. It becomes 0 galvanometer, so the indicator on a 0. Okay, there is no any current which is flowing from this 5 ohm resistance. And what they ask, the current passing through the 5 ohm resistor. So the simply we can say answer is equal to 0. So actually fundamental is you have to just detect if this Wheatstone bridge is equilibrium or not. And in our condition, in our board level, it is a normal fundamental, and also question are going to ask from this fundamental that Wheatstone bridge, just detect that it is in a equilibrium condition. If it is in equilibrium condition, the current flowing from that center resistance is equal to 0. If there is a single resistance, if there is a combination of resistance, do not worry, from that entire middle loop we can say the amount of current is equal to 0. Done, dear. So from here I give you some of the questions. Yes, some of the questions for your homework, and always remember, good things take the time. So it's take your 12 year. It takes your 12 year before your board exam. So give your best and achieve the best. Just one wishes from my side for all the dear students. And in a last, trust yourself. Trust yourself. You can do it. This single statement keep you very positive for upcoming days, and that positivity has the power to get best output whatever yourself can make that things. Okay dear, so try to best to become your best. મતલબ કે જો તમારો મતલબ કે જે આઉટપુટ ડિયર આવી રહ્યો છે એ હવે આ લાસ્ટ દિવસોમાં ઇન ધ લાસ્ટ ડે try to get best out of your own self, compete with your own self, and whatever we get it is the best, whatever we get it is the best things here. So maybe we are just try to conduct one session for our English medium students on a demand. If there is another demand, if there is some demand for the another subject, other subject, we are trying our best. We are trying to plan something for you also. So if you really need this type of session for physics, for chemistry, for biology, for maths, just write down in the comment section. Also, after a long time I take some session for the English medium students, so it is also very excited things for me to do, and I am totally happy for that things. So just I wish all of you to also give your experience in the comment section. Maybe it is motivational for me, maybe there is something from your comment that I have to be learned to improve ourselves also. Okay, so finally thank you all of you, and best of luck for your upcoming greater future. Have a good day all of you. Jai Hind.